Alright gang, today we have a U5000 in for repair all the way from Australia. And this was sent in by a viewer by the name of M. Reed from Australia. I just hope it's not Lex Luthor using a pseudonym.
Lex Luthor, ruler of Australia.
And he is saying that the HOT keeps blowing, so he picked this up off of eBay and got it working, and then while he was trying to make some adjustments, the HOT died. And let me show you what he has sent here. Says, here's my U5000 chassis, which has a really annoying issue. The HOT keeps blowing whenever I power the chassis and the deflection board just ticks. I need your diagnosis. Got this from eBay. As soon as he got it, proceeded to replace the caps. Chassis worked fine, so the caps are not the issue. After powering on, the picture was a swirl of colors, so assumed the degal circuit was bad or tube was severely magnetized. To be sure nothing was bad with the color circuitry though, I started tapping around U701 with the back end of an insulated screwdriver, and then the CRT shut down and the HOT blew. Not sure what caused the chassis to do that from just tapping around U701 and Q703, but something must have shorted when open and caused a voltage spike. So before replacing the HOT, went ahead to the upgrade recommended by Wells Gardner, blah blah blah. So there's a power supply upgrade service bulletin. Then there is a vertical sweep upgrade kit as well. Neither of these should cause HOT to go out. There's a very specific series of circumstances that would cause that, but he replaced the flyback, the HOT with the Fujitsu series that I recommended, although what's odd is that that's not what's in here. This is an original C30688. The Fujitsu that I recommend is let's pull this out here and you can see, I actually only have one left. It's the FJL6920. The FJL6920, this is the one that I recommend, and I put in all these that I repair for a while now. So when he says that he replaced the HOT with the Fujitsu series, that's not what's in here. Now, it very well could be that he replaced it and it blew out again, and he replaced this with the only one that he had on hand, which is very likely, but we'll have to, that's my last one, so we need to get this fixed before I put that in there. Otherwise, it'll just go out again. I replaced U701, replaced Q703, resoldered and testing many connections, pulling some film caps out of circuit and testing them, replacing R121 and R101, the thermistor, that's this thing over here, this thing, R121, yeah. So anyway, we've got, it's blowing HOTs, long story long there. So what we need to do is, first let's test the HOT and see if it's actually shorted. That's going to be just step one, easiest thing to do. So we'll grab the meter and we'll go to the diode mode, and the center pin should be negative lead, and to each leg should be a 0.5 voltage drop. About 0.46 something or other, but we're looking for 0.46. 0.221. 0.221. That is not a normal reading. That is a very odd reading. That is not what you'd want to read. Well, that's issue number one. Why are we reading something crazy like that? I noticed that the 10K ohm ceramic resistor that's normally here for R104 has been changed out to this film type. I don't know if it's a ceramic still, but it's definitely been replaced. Does it read 10K? Yes, it does, so that's fine. I see something else here. This capacitor in here is supposed to be a 100 volt 22 microfarad, and they've got a 50 volt 10 microfarad in there. Not sure why that's like that. Now I wonder if there's other caps that are the wrong rating. See, now here, C725, they've got that 22 microfarad cap here that should be here. Hang on a second. I just happen to have a U5000 here, and Okay, so 250 volt 22, so that's fine, but that one's supposed to be 100 volt 22, and they've got a 50 volt 10 in there. I don't think that'll cause the HOT to go out, but that's a discrepancy because that is supposed to be 22 microfarad. Now, is that part of this? Is that part of this service bulletin? HOT to fail, and sometimes R728, Q703, 708, R760. So none of this has anything to do with that capacitor. MOSFET, pad, amp, diode, resistor, fuse. This is the vertical sweep mod. That's got nothing to do with that cap. Well, why that cap's the wrong one? Wait a minute. What is this? C613. Well, that's not this one. That cap is C117. So, yeah, I'll have to change that out to a 22. It's not really going to affect anything. It shouldn't, but that's an issue. So I guess we can remove the jumper here and do the light bulb test, but I want to get this HOT out of here first, and I need to go through and make sure that there's not... See, I'm not sure about this here. Look at... There's a couple of 4.7 caps here that aren't all the way down because they're the wrong size. They're 160 volt. They don't need to be one. They need to be like 50 volt 4.7s. But they're... It's like that, I don't know where this cap kit came from, if these are caps that he had on hand or if this is a cap kit he ordered from somewhere, but it's not correct. Well, it's correct, I guess, the ratings, but I'm going to have to go through here. If you got it from Arcade Parts and Repair, maybe these are the only ones that they had on hand, and I'm not sure, but, you know, I'll have to go through here and verify all the caps are the right rating. But for the moment here, let's just get this HOT out and see if those pads still read that 0.2, whatever it was, because that's not a normal reading. Because if they still read 0.2 with the HOT extracted, then we've got some further troubleshooting to do. Now, the HOTs blowing on these, in my experience, are really only caused by one thing. You know, well, I say two things. Either the flyback has gone bad, which they put a brand new one in, or R760 and R765. One or both of those resistors will go out of tolerance and will cause the HOT to get taken out. So we'll pull this out of here and then inspect those resistors. I think this might be the HOT that came with this power upgrade kit or whatever it is, service bulletin, because this thermal pad is new also. And I don't see any burn marks on here, so seems all right. Yeah, what does this read out of circuit? Oh, dummy. Yeah, 0.2. See, you shouldn't get a reading to each leg. It should be just one leg. That's 0.2 and 0.2, so that's not right. This may be a counterfeit, or it may have been damaged. See, now if I go to this one, see, there's open to this one. That one's open. This leg is our 0.4 voltage drop. I usually round up, but 0.6. So you should not have continuity to each leg. See how there's 0.2 on this leg and 0.2 on that leg? So that's wrong. That's not correct. This one you see only has it to 1, 0.3 and nothing. So that's how it should be. So something is not right there. Now if we go back to the pads and check those, I don't think that you're supposed to get a reading on that, but not 100% positive. But anyway, so R760 and R765 are only present on the U2000 and the U5000. The K7400 and 7500 don't have them populated. But if we look here, R765 is right here, this guy right here, and it should be around 33K if I recall correctly. It's been a while. 32.8, that's fine. Then R760 is this guy right here, this taller one just forward of it. That should be around 500 ohms. And 463. So those appear to be okay. And looks like someone's replaced this one. It's kind of a smaller wattage than it should be a larger wattage one. I'll show you. It could be part of that power upgrade kit, but see the wattage of 760 right there on that one? And then this one here is a much smaller wattage. Right there. So that's odd, but you know, if it reads within, it shouldn't cause HOT to go out immediately. Okay, well, the Q703 will cause, if Q703 is faulty, the chassis won't even turn on. Let alone, it won't blow the HOT, it won't even turn on. But let's test it. Q703 is usually the cause of a dead chassis, not a HOT going out. But we'll test the pads here. This one should go to here. That's fine. This one goes here. That's fine. This one goes here. That's fine. Okay, so now let's test this one. 0.6 and 0.6, so that's fine. Looks like a decent job on the reflow. Got the remote header pins, neckboard header pins. They didn't get the video input header pins, but they look okay. All the header pins for the resolution selection jumper, that's good. Looks fairly good. Yeah, not too bad. There is some stuff that needs to be hit, but otherwise not bad. Q701, yeah, that all looks okay with the socket that was installed. And looking at this here, it does look like this trace is lifted a bit on Q703, but it had continuity. Yeah, that's fine. Well, let's do our power supply check, because with these resistors checking okay, 760 and 765, this thing reading all out of whack. It looks like someone's replaced R728 also, this guy here. Is R728 on this list? Yep, R728. So that's part of this service bulletin. Well, let's do our power supply check and verify that we got a good B+ and all that jazz, because nothing really looks like it's out of spec. Nothing appears to be immediately jumping off the tail of it, but like this is supposed to be, I think, 16 volt 1000. They got a 50 volt 1000 in there, and these should be 50 volt 4.7, and they're 160 volt 4.7. So I mean, the voltage isn't the issue as long as the rating is correct, but it just, why use the higher voltages when they don't need to be? Okay, yeah, they did the 50 volt 1000 down here too instead of the 16 volt. 25 volts usually what are in the kits, but anyway, okay, well, nothing is shorted, because if something on the HOT circuit was shorted, we would see that when we do this. Nothing is shorted, but what's odd is I don't know if that's a normal reading with the HOT out. I want to try something here. Let's take this U5000 that's working and desolder, not the entire HOT, but just that leg of the HOT. Just this leg right here. And let's see if we get the same reading on the diode, because I'm curious if that is a normal reading or not. And I'm also curious if I'm going to be able to separate this to where it's not touching anything else on the... I think that'll work. Okay. Let's just see here if we can. Okay, so that's still touching there. Now it's not. Okay. So I have successfully removed the pin from the pad. So let's see if we still get that reading. So negative on the pad and to here. See now, there we go. We got a voltage drop there. Wait a minute. It's still, yeah, you rat bastard. Stay over there. Nope. Ah, come on. What? There we go. Okay, yeah. Oh, nope. Okay. So, all right. So I got 0.9 by doing that. And I'm going to forget. So we're going to do this right now. Because I will forget completely if I set this aside. All right. So 0.9 with that leg out. And what do we have on this 1.8? So apparently that is a normal reading. Okay, just wanted to verify that because I wasn't sure. But we get a beep on this one. Not that time, okay. Another one's 0.9, that's 0.89. So, okay, so that appears to be a normal reading. Just wanted to verify that. All right, so let's just do our power supply check and see what we get. I only got one HOT. Now, if we blow it, I can steal an HOT from another spare chassis and then order another one, order more and replace the ones that I stole later. I mean, that's not going to be a big deal. But I want to get this one working. But here it is. I also want to not blow a HOT. So actually, blow is the incorrect term. Short. I don't want to short the HOT. All right. So our W159 jumper is extricated. Now we can grab some leads here and we'll clip one lead on here and another lead on here because one of them is going to go to our meter for voltage like so. The other one's going to go to our light bulb, and then as far as for the ground, we need one more for the ground here. For the meter, so we'll clip on the ground right here, and then we'll grab our negative lead, clip on there. All right, so now all we need to do is grab our light bulb, plug in our power. By taking that jumper out, we remove the B+ output to the rest of the chassis. So this whole portion of the chassis here is dead. All we're testing is the power supply. So safe to do this on the bench without a monitor. So we're set up for read our negative and our positive. So we'll take our lead and touch it here for ground and touch this for power, and that should light up. And we should get around 130 volts or so under load with this wattage of LED. I think this is a 10 watt LED, so I think it drops it to around 130 volts. So let's turn this on, 1, 2, 3. Okay, so we have 165 B+, 166, so this should go down to 130 when we use this light bulb. So here we go, 1, 2, 3. Okay, we're 128.9. So our power supply is functional. All right, let's turn this off and this should start going down. And to dissipate this, instead of just sparking it across the heatsink like I used to do, we can use the light bulb to dissipate it. So the light bulb will light up and then dim real quick. Blue. And you'll see it's 50 volts, 49, 48, 46, 5, 4, 3. Or you can just go like this real quick, tap, tap, tap. And now it's dissipated to 0. So, all right. That is a functional power supply. R760 and R765 test fine. Well, I mean, unless the flyback is faulty, it shouldn't be. It's brand new. And, you know, unless there's a capacitor. But he said he ran the chassis fine with the capacitors the way they are. And it wasn't until he was tapping around over here that something got taken out. But if it's a non-metallic screwdriver, it shouldn't have mattered. It could have just been complete. It could have been just complete coincidence that he was tapping on that stuff when it decided to die. It might have died anyway without tapping on it. It was just might have been just coincidence. So the general things to look at have been looked at. Q703 is fine. Like I say, that if this was bad, it just wouldn't even power on. You know, so I don't know. Obviously, I don't think it's anything that they did because it died prior to doing any of the mods that were performed. I wonder if it's a bad connection on the jumper here. They all appear to be okay. This is also what looks like a low hour chassis because the heat sinks aren't all, it's not all burned up. There is some heat damage, but not like, I'll show you another one. Like, look at this one. Look at this one compared to this one. So you can see here we have a high hour and a low hour. So, yeah. Well, what do you think, gang? Should we just try it? Maybe there's something wrong on his end. Maybe. I don't know. Like I say, if we do take that out, I can steal that HOT from that one I just showed. I've got a couple of spare U5000s that I can steal parts from, and then replenish those later. But I don't want to have to do that, you know. That's not ideal. Not ideal in professional troubleshooting. But this is not the professional channel. Okay, that is back through. We can go ahead and put this HOT in just to see if it reads properly. And it could just be a situation where they had a faulty part and it may work fine now. Actually, what I'm going to do is I'm going to put this here. Make sure it's all insulated. Yeah, we're going to put the screw through here. To avoid trying to line it up and possibly damaging the pad. Try and line it up as best we can. And then push it and hold it. So stay there. Then we're going to get tweezers here and use those to put the screw on. Oh, I mean the nut. Put the nut on the screw, I should say. Come on, what is your major malfunction? There we go. All right, just nice and snug. You don't need it to be super tight. Let's solder this in here and see what we read now with this replacement in there. Because if this HOT shorts, something is very wrong. This FJL6920 is super robust, and it's basically a replacement for everything out there on the market. I mean, if you got an HOT that died, this is pretty much just the universal replacement for it. Whether it's Neotech or the D9200 or the 2000, 5000, 74, 75, I mean, yeah, this is pretty much the universal replacement. All right, solder looks good. So if this one gets taken out, then there is definitely an issue. Okay, nice and clean. Okay, that's all reinstalled. Well, okay, I mean, power supply is functional. R760, R765 are good. Q703 is okay. And I don't know if it shorts immediately or if it runs for a few minutes. I don't see anything visually wrong, like, you know, broken traces, lifted pads, things like that. So, yeah, I mean, I say I'm game to just try it. I do want to reflow these horizontal yoke header pins here because these didn't get reflowed. I say reflowed, but technically reflowed means remove original solder and add new solder. Well, technically yes, but you know, for the purposes of this, it's easier to just say reflow than add a little bit more solder. So, okay, yoke header pins, new solder added. Okay, well, oh, I forgot to, I can disconnect that. We forgot to check the reading now with the new HOT in there. So we should get our 0.45 voltage drop or so to each leg here. So negative in the middle to each leg. Okay, 0.3 and 0.43 and 0.43. That's much more normal reading. So, and again, it reads out of circuit. You saw it only read to that left leg. The right leg was open. Well, it's going to read to both legs in circuit because these two legs are tied together in circuit. See, so that's normal. So you're going to read that anyway. So I guess let's just try it, see what happens. I mean, worst case scenario, it takes the HOT out. I'll just grab another one from another chassis, and then we'll continue troubleshooting. But this is all tied up here. And I'll replenish the ones from the ones that we steal later because I have to order more anyway. That was my last one, so might as well see what we can figure out here. No guts, no glory, as they say. Okay, that's in there. And this must have been... Wait a minute. How did they have this connected? Did they not try it after they changed the flyback? This is the G2 wire. For your edification, there's two wires that come off the flyback. There's three. This one goes to the tube, obviously, but there's a thick wire and a thin wire. Disregard the colors completely. The thick wire is always the neck, and the thin wire is always your G2. But how did they have this connected? Because there's no connector on here, and they still got the pin. Did they try it after they changed the flyback? The note doesn't say that. It just says replaced flyback, replaced HOT. The rest of this paragraph here is all about the light bulb test. Well, there's no way to connect this. So I'm just going to remove the pin like I normally do, like that. Pin is out. And then we'll just solder the wire right through the hole. But I'm curious how they were testing this without having the G2 wire hooked up. So let's get that in there. There we go. Perfect. All right, well, turn my fan on here. Now let's get this plugged in, and the remote board. Okay, and let's start by turning brightness and contrast all the way down. And the screen pot, well, that's already all the way down. So I can tell because the screen pot is all the way down and the G2 wire was never hooked up. I'm gonna bet that this was never even tested after putting the new flyback in. So, well, I mean, I guess that's about it. Let's just fire it up and test it and see, you know, maybe the old flyback was bad and they never tested it after replacing the flyback. If they did, I'm curious how they were, because not only was the screen pot turned completely down, which is normal for the new flybacks, but the G2 wire wasn't hooked up. I don't know how they had it hooked up. There wasn't any evidence of it being soldered to the backside, and there was no connector on it, so interesting. Well, let's get a tube over here, get this hooked up, and see what happens. Okay, so we're all hooked up, ready to go. We got anode, neck, yoke, ground, power, video, remote, the critical 7. Never turn a chassis on without counting to 7. And I did notice a couple things. So before we turn this on, a couple things here. The neck board color pots were all off. So all 3 bias pots were completely turned down to 0. And the drive pots for green and red were about like 65%. So I put those back to about 50, which is where I like to keep them. But all 3 bias pots were completely down to 0. So I turned those up to 25%. These series of chassis, the U5000, 2000, 7400, 7500, those don't like to be higher than about 25% or the colors begin bleeding. So I put these at 25% just as a base setting. So those weren't even hooked, those were all at 0. And I'm going to use the TPG here just for ease of testing, because I don't want to run this with a real PCB in case something goes bad and it zaps the video ground line or something. So we're going to use a TPG. So we're set to standard res. That's what we're hooked up to, standard res. And then the sweep mod, you have to have the connector here. There's a white wire. There's a white wire in this 2-pin connector and then a black wire that's snipped off. The white wire has to be hooked up to this 30-volt reference pin for standard res. And it needs to be hooked up to the no connection here for the black wire for this pin for the medium res. So right now we're hooked up with the white wire for standard res. So we'll test medium res here in a minute if this works. So yeah, I guess that's all. Oh, the second thing I wanted to mention was this did not have the little protector here. So I had to rob one of those from another chassis. So obviously you don't want to run this without the little standoff here, the plastic standoff. So I had to rob one of those. So we're all set up in here, secure, ready to go. I'm going to turn my little fan here off in case something explodes. We can see what it is, where the smoke's coming from. So, all right, is it going to work? I don't know. Flyback is turned all the way down. Brightness contrast turned all the way down. I don't want to overdrive anything. I just want to see if it turns on and runs here. So let's find out. 1, 2, 3. No, it's on. It's making an odd noise though. Okay, I'm gonna turn that off. Okay, TPG is now on. I just wanted to see if it turned on and ran, and it did, so TPG is now on. Let's see if anything happens now. 1, 2, 3. Okay, it is running. Gonna let it run here for a moment. Seems okay, so let's turn up our screen voltage here on the flyback until we see something. Okay, there's our raster. Let's turn it down till it's black again, right about there. Okay, so far so good. Brightness. Nothing with brightness. Probably need to turn it up a bit more on the flyback, but contrast brightness is up. I'm not getting an image. We're running. Let's try our screen pot again. Oh, we've got no image. Brightness and contrast are full blast. Screen pot is up. TPG is on. I'm going to turn it off. Back on. So we do get a little bit of something. Oh, I can... Oh, wait a minute. Let's adjust our focus here. Okay, so there's something. H position needs to move over. No, it doesn't. Right about there. So, well, no. Yeah, it needs to be about, I'd say there. Well, this is what we get. So let's turn our flyback back down until the lines go away. Ah, now we're cooking. Okay. Contrast. Right there. Brightness is all the way up, so let's turn the brightness all the way down. Well, that's about where it needs to be, because anything more, it's going to be too much. No? Let's go more. Basically, you just want to have the brightness set to where the background is black. So if we turn that to right there, and then brightness. Okay, so now, right about there. Now we need to tweak our focus a bit again. Right there, looks pretty good. Well, it's working, you know. The colors are pretty dim. I can't turn the contrast up any more than right there. And this tube is normally weak, but we've got no red. I wonder if we could just simply turn the drives up, or the bias pots. Like I say, normally they don't like to be higher than about 25%, but maybe, oh yeah, red just bleeds. So right about there. Terrible colors here, just terrible colors. Now it's not my tube. Tube is fine. The tube is slightly weak, but it's not this weak. Something, I wonder, I'll tell you what, let's turn this off, switch this over to the black jumper that has no wire in it, flip this over to medium res, and I'm curious if medium res is as dull. So medium res on and on. Let's see here, trying to get that glare off the... Holy cripes. Well, this is functional and operational, guys, but I'm telling you, what is going on here? H position, right about there. Good Lord, that is just terrible. And it's not the tube. It's not the TPG. Those colors are just terrible. But it's operational. I'm wondering if there's some kind of, I wonder if R811 is faulty. I wonder what R811 is. Let's turn this off. I gotta let it sit for about 5 minutes to cool down. I wonder what R811's reading. I mean, it's looking better, but even if I use a regular board, it's gonna be even worse because this has higher output, higher video output than a standard PCB. So with a regular PCB, it'll be even worse. And I can't turn the colors up because watch what happens if I turn up green, for instance, it just bleeds. See, so right now these pots are all about 25%, just like I said, and anything higher than that, they start to bleed. So is red still, see, red's a bit better on medium res, but something is funky, and we're not, we gotta turn the brightness down a bit too, because see, we're too bright here. Right there, that's where it should be. And it's just super dim, and it's not the tube. So let me do some tinkering here, make some adjustments more, and see what I can do. And then I'm gonna turn this off for about 5 minutes. So we'll test R811 and see what R811 kind of reads, and see where we can go from there. Because I'm also kind of want to swap out the neck board to a different neck board, because maybe these transistors are bad, or I don't know. Maybe the RGB chip is going. I don't know. Maybe there's a cap that's the wrong reading that's causing this. I don't know. But this is super dim. And it is not the tube, because I just ran this with another 5000 and it was glorious. So it's not the tube. Something is happening here. Let me do some poking around and see what I can find. All right, so R811 checks out fine. It's supposed to be between 50 and 100 k ohm, and I read 63.7 k ohm. And it resides right on the U5000 and the U2000. Oh, sorry about that. I hit the viewfinder. The resistor resides right there, that guy right there, R811. And it reads between 50 and 100 at 63, so R811 is not our problem. If that is bad or out of tolerance, you can have a black and white image or muted colors like we're experiencing here. However, that wasn't the cause. So I removed the original neck board here. You can see it's still got the little ID tag here that he zip tied on. And then this is that one that had the much higher hour operation that I showed from the other one. I just soldered the G2 wire to the back because it's got the pin as well. The other setup has the proper connector, so I just soldered to the back instead of taking that pin out. Anyway, so this has been off for about 5 minutes while I've been changing things out and testing R811, things like that. So let me show you what it's doing now. I am going to turn this on, 1, 2, 3, and let's see what's happening now. Any day. Well, look at that. Look at how much better that is. Look how vibrant, and man, look at that. Fantastic. Let's go to regular RGB. Whoa. Outstanding. Something on this neck board is muting the colors. And I suspect that it's this resistor. Now, what's actually probably happening is it's limiting the G1 voltage or the heater voltage. I bet you it's muting the colors due to that voltage being much lower. And you can see how nice and vibrant this is. Now, if I was to, let's see if we can do this live. You can see how good this looks. I'm not going to touch anything. I'm going to turn this off. And let's see if I can switch out this neck board here kind of on camera so you can see. So let's disconnect this nice and slow. Ground wire, focus wire, ribbon cable, G2 wire. Okay, so now this one is removed. And I'll reattach it to the original mother chassis later. So let's solder this G2 wire back in. Am I lucky enough to have it go through without? No, of course not. Bending on me. There we go. And we'll solder that in. All right, that's in. And focus wire is in, wrapped around, ground wire, and ribbon cable. All right, now let's hook this up, and there we go. All right, so now let's try it again. I'm going to take my iron here and put it away. There we go. Okay, now, so now we have it swapped out. Nothing has changed. Let's turn it on and see what it looks like with that neck board on. Oh man, look at this. This is taking forever. Look at this. That neck board is the absolute cause of this muted color issue. Oh my Lord. Wow. You can't even see the red. Nothing. The red is there. It's there. You can barely see it. There it is. But oh my, holy cow. Let's take this neck board off again and see if we can figure out what is causing these terrible colors. Okay, so on the left we have, fold that back up. On the left we have the one that's working, and on the right we have the one that's not working. I got the cap, there's a cap on the back side, and just notice that. So working, not working. And I suspect that it's this R500 resistor here. So if we look here, on the one that's working, the R500 is 0.1 ohms. And that's because we've got a jumper under this. If we look, there is a jumper that jumpers. So that resistor is going from this pad to this pad right here. But you can see it's also the same trace as this. So there's a jumper here. So you're going to read 0.1 because of the jumper. So if we read across that again, we get 0.1 because of the jumper. But if we go to this W500, we get 6.3 ohms because that jumper is not there. That jumper has been cut. Now if we were to simply do this, you can see that that jumper is gone. That jumper is gone. So I don't know if this is a mod that somebody did to try and lessen the colors or mute the colors, or really what is going on with this. And it says right here, the picture was a complete swirl of colors, so I assumed the degauss circuit was bad or tube was magnetized. Now you would think that's a degauss issue, but I wonder if this might be part of that particular problem, because I don't have his tube he was testing with, but there should be a jumper there and someone has cut that jumper out. So with that removed, I wonder what that reads. Let's make sure it reads the same as the other one here. We get 6.2 ohms, which is what we had before, but I'm dummy and forgot that. So if we remove this resistor, what does this one read? .5. Well, I'm not going to sweat 3 ohms, but what I want to do is reinstall that missing jumper and then test it and see what it is. Now, I don't know why somebody would have removed that jumper, but there's all kinds of different revisions of these neck boards, and that could have been a mod that was needed for whatever particular type of tube they were. I mean, maybe the colors were being way overdriven on whatever tube this was being used on originally, this one. And I think maybe trying to mute those colors on that overdriven tube, they got rid of that jumper. But what's happening here is we're limiting the voltage to the tube for the color generation, which in this case would be the heater. So I think we are limiting the G1 voltage by having that jumper gone. So what I'm going to do is I'm going to reinstall that jumper and just see if that'll bring back our colors. Come on, you piece of junk. That's better. Okay, so I need to grab a somewhat beefy solder leg here, and we'll just add that jumper back in on the back side, and we'll just grab this 250 volt 100 here. And if this works, I'm not going to sweat too much the other caps that are the higher voltage rating and things like that, because if it operates, it operates, and I'm not going to worry too much about it. And if it looks good and has the right geometry and all that jazz, then we'll call it fine. But we're just going to add this jumper on the back side just for testing here, and all right, that'll do it. And we'll still be able to use our cap because there's plenty of legs still. Not going to sweat that either. Okay. Well, there we go. Now, what do we read across our resistor? Should be 0 ohms. 0.0. So, yeah, let's hook this back up and see if we get our colors back. All right, here we go. Neck board is fully reinstalled. let's turn this on and see what difference that jumper makes. Here we go. 1, 2, 3. Okay. Let's see. Look at that. Look how much faster that comes up now. Wow. Let's go to RGB. There you go. I don't know what that mod did or why it's there. That's why this is the amateur channel. I haven't looked into it. Like I say, there's so many different revisions of the neck boards and things like that, and service bulletins and whatnot, but with that jumper removed, we have almost no color output. It's just completely killing the G1 voltage if I was a betting man. And now with that jumper in there, we get our proper G1 voltage and boom, fantastic. So let's try it with some actual PCBs. We'll try a Cruisin' USA and a WrestleFest and all that. Now, why this stupid camera does not like the exposure kills the red. You can see how it looks like the red is fading. That's in camera only. That is not happening in person, believe me. See, if I zoom out, there's the red, just as bright as the rest of them. If I come back in a little bit, it darkens. That's all purely in the camera, not in person, believe me. So anyway, all right, so let's get some, let's go back to the color bars here, actually. There. So I come back out of it. So I mean, yeah, the red in person, the red looks fantastic. It's just the camera, this is just a cheap camera, I guess. So let me hook up some actual PCBs. We'll go through, do some adjustments and testing, verify it works on real boards, and kind of go from there. All right, switching here to the iPhone for the handheld because I was using the overhead camera that I normally clip onto here for the handheld mode, and it looked terrible and it was shaky and I couldn't get, it was picking up the red all messed up, and I realize how bad and unprofessional it is to try and do that instead of using a tripod. But the problem is to try and use a tripod, I have to remove this clamp, and it's so picky to try and get it back correctly set for the overhead down shot. So I don't like to remove it, and so that's why I'm just using it to handheld, and it looks terrible, and I'm sorry about that. I thought, okay, so for the final result here, we should probably use the iPhone because it's going to pick up the colors better than this thing does. But our problem is solved, but let's just see how much better it looks with the iPhone here and with actual PCB. So we have Cruisin' USA. We're still set to medium res. TPG is over here and off. So let's turn this on. And let's just see. Oh, we're going to have to make some adjustments here, of course, but we're going to have to... and the TPG has a much higher video output. So again, this will be something we have to make adjustments to. So let's just start with contrast and brightness all the way down. Okay, so right there, the screen voltage is going to be fine for right there. So let's turn this up until the background's not black. Back down till it just is black. Contrast up. We're bleeding, so we'll turn it down till we stop bleeding right about there. And oh no, we're still bleeding here. Holy crap. Let's contrast down there. All right. That doesn't look half bad, but we need to make sure our width works. Yep. Both sides. Yep. Vertical height. Whoa, the pot's a bit scratchy, but it works. And vertical position right about there. So H position, now that I lost my screen there, H position will shift over to about right there. And yeah, that's about even right there. Okay. And we're gonna have to adjust colors here. They're pretty bad, but we got a full square image. Look at that. Focus a bit more here. Let's do this tube. About there is about as good as it's gonna get for this tube, but that's pretty good. Green is too green. We'll turn green down a bit. Okay. There you go. That's looking pretty darn good. Okay, fantastic. Look at that. So let's switch over to a standard res game. So we'll turn this off. We'll Move this jumper back over to the pin with the white wire, and then we'll move this over to there, and let's grab a standard res game. We'll just simply set this here off camera, and we'll grab this board here, which just happens to be WrestleFest, and let's hook that up. Okay, there we go. Easier said than done. All right, now let's see what happens with WrestleFest. 1, 2, 3. Okay. And yeah, so again, medium res runs a bit higher output than standard, and then this runs the higher output than even that. So you can see how much darker this is than we just saw on the medium res. So, you know, these are designed to run on a specific input, not be able to be just swapped back and forth easily. If you swap the input, you're gonna have to make some more adjustments and things. So, and of course, this is different resolution than this. That's why this is like this. So now we have to readjust brightness to there. Contrast we can turn up to roughly, see, like I got contrast maxed out and it's not bleeding. So actually, yes, it is a little bit right there, right about there. So now we need to do H position to there, perfect. Vertical position to, I'd say, there. Now we need to do height, shrink it down a bit. Oh, that's hold. Vertical size was height, so right about, oh, let's say there. And yeah, there you have it. Still a bit too green, I think. Let's turn the green down slightly. There we go. All right. Awesome. Now, well, there you go. I don't think we actually found a discrepancy, except the HOT here was probably, I don't know if it's counterfeit or the wrong, it's the right number, 3688, but I don't know if it's counterfeit or it's not able to hold up to the stresses or really what, but we put the FTL 6920 in there and it didn't look back and it's working fine. So again, let's review on this. So you got a HOT that's shorting out. You have to look at R760 and R765 are the two likely culprits. If you change out the HOT and don't find anything else wrong and it blows again, then I would put the FTL 6920 in there. If that one gets taken out, then you actually have a problem. But the 6920 is much more robust and is able to obviously hold up much better. So we obviously don't have an actual problem, or the FJL will be getting taken out as well. And I also want to say that if you take the HOT out, make sure, it's very important to check the pads. Make sure the pads aren't shorted. If the pads aren't shorted, then there's nothing else on the circuit that's actually shorted or faulty, and it's likely the HOT just simply died due to age. Or you might, you need to do this upgrade, but I've never done this upgrade on any U5000 I've ever worked on, and I've never had a problem. So anyway, if you want information on this, you can just Google, you can Google it. Let me look at it here. Let's see here. Service Bulletin Kit S01J0000-000F. Horizontal output update. So if you want to just Google this, you can go to Mecha Arcade Repair. George Spanos is a great guy. All the information is there. So if you want to do that, but I've never had to really do it. I think this owner did this out of desperation, but I don't know. All I did was put the FJL 6920 in there and it turned on and worked just fine. So I don't think anything was actually wrong. I think whatever they were trying to use here was just either out of spec or not able to hold up to the voltage or bad. But anyway, so that's about it. We had the missing jumper that was causing low G1 voltage, low video output, and we had a faulty HOT. That's about all that was wrong. So I'm going to go through and maybe do some more strategic reflow. Obviously, having that 10 microfarad capacitor there instead of the 22 isn't that big of a deal. But otherwise, yeah, I think we're good to go. not much else needs done. So missing jumper and a bad HOT, and that's about it. So I'm kind of hoping it was a little something more detailed, just for the sake of the owner of this, but it was just the HOT and a missing jumper. So that's it. Thanks for watching. Hopefully you learned something. Like, share, and subscribe, and we'll see you next time.